Today we are going to go over some CS problems to further understand the concepts that we have learned through our lectures. So the question is to write a function named mySum given two variables and return their sum. So we have function sum is equal to mySum A B. So what this is saying is that we will later use this to state what this is, and then these are our variables that we will input later. So then sum is equal to A plus B, and then we write end. In the command window, you would write mySum to call on your function, state your variables in brackets, and then it would return 11. Our second example is to write a function named allOdds. We can only use two integers, and the second integer, odd or even, represents the max value of the output vector, and it may or may not be included. Our return is a vector that starts at the first integer and has an upper hand of the second integer, contains only odd integers. So you'd write function, the name of what you would like to return for the first variable, and then name your vector, and then give it two variables. Then you will define what this is, and you would start at an integer and you would move by two spaces so that it would skip all even numbers and end at B. Because you're using colons, you don't need these brackets or the parentheses, so we can get rid of those. And then end, which isn't always needed. Don't forget to suppress your function by putting a semicolon in the end. And if, for an example of this, you would have you have allOdds 1 to 8, and it would return the numbers 1, 3, 5, and 7. Next, we're going to write a function named myMean. You can only have two variables, which changes things up a bit. Because you can only have two variables, you have to think outside of the box and use different pieces that you wouldn't originally think of. So you have function, then I like using ANS, is equal to myMean of A. Actually, we will only be using one variable. That's all we actually need. Your answer is going to be the sum of vector A divided by, and remember to use the dot and the slash sign when you're doing this, divided by the length of A. Although the length of A is only a scalar, it's good to get in the habit of this. Don't forget to use the semicolon and then end. So if you were doing this as an example, it would be myMean when A is defined as 1, 2, 3. So my mean of A. And you would get sum of A, which is 6, divided by the length, which is 3, and you get 2. For our next problem, we're going to go over the logical operators and their tables. So we have AND, which is the ampersand sign, and if A, B, and we have A and B. So if A is false, B is false, then A and B are both false. If A is false, B is true, then A and B are both false. If A is true, B is false, then A and B are both false. If A is true and B is true, then A and B is true. So the rule for the and sign is that all must be true for A and B to be true. And now we'll go over the OR table, which is basically just the opposite of the truth table. So OR sign is this big long line, and you have A, B, A, and B, just like as we had, or I guess it's A and or B, A or B this time. And here we have if A is false, B is false, then A or B is false. If A is true, B is false, then A or B is true. If A is false, B is true, then A or B is true. And if both A and B are true, then A or B is true as also. We're going to go over real quick the all and the any. All says that if everything is true, if one is true, then everything is true. And if there's one false, then everything is false. The any says that if there's true, that it's true if anyone is true, and it's false if only everyone is false. So basically, just think of true to both of these. If all are true, then it's true, but if there's one false, then it's all false. If there's any true, then it is true. If there's one false, or there has to be every false for it to be false. So default to true when you're thinking of these. Now that we've reviewed our logical operators, we can do this practice problem. B is equal to the vector where 2 is less than 5, or 2 is equal to 3. So 2 is less than 5, that is true. But 2 is not equal to 3, it's false. Because this is an OR, then and 1 is true, then the B is equal to true. We're next going to work on the statement C is equal to not A divided, or not A or B. Now please keep in mind that this is not the same as C is equal to not A or B. This is applying the not to both A and B. This is just saying that the not is to the A. Okay? And A is equal to 2 is greater than 5. B, or is less than 5, I'm sorry. And B is 2 is equal to 3. Okay. So originally, A is true, and B is crap. B, as we just found out, was true, and A is the function 5 divided by 2 is greater than 1, which is also true. Okay, so A is true and B is true, but it's not A, so it becomes false and B is still true. Because both are true, C is equal to true. Alright, so we're going to work out this problem now. I've already done A and B. 5 divided by 2 is 2.5, which is greater than 1, which is true. 4 is not greater than 5, so B is false. C is equal to 1, 3, 10, which, this is start, step, stop. So we have 1, 4, 7, 10. D is equal to 20 to 27. So 20, 22, 24, and 26. Remember that your end number does not always have to be in your output vector. Alright, so E is equal to C, A, B, A, B. So what that is saying is that you take vector C and you plug in the numbers true or false. If it's true, the number will stay. If it's false, it will disappear. So what we have is A is true, so 1. B is false, so 4 goes away. 7 stays, and 10 goes away as well. Alright, it's basically the same thing for F, except we're using D, so the first two are false, so they go away, and we're stuck with 24 and 26. Alright, so G wants us to use E2, which is 7, and multiply that by F1, which is 24. And you get the answer 168 as G. Remember that when you multiply, you have to have this dot before the operator if it's if you're having two vectors, but a scalar and a scalar you don't need it, although it is nice just to remember, and a scalar and a vector you don't need it, but then again it's just good to remember. Next we have the function A, or the statements, A is equal to all, and the vector true, true, false, true. B is equal to any false, false, false. C is equal to 1, 2, 3. D is equal to C times the vector A, B, A. Here we're actually going to be replacing values. Alright, so let's get started. All, remember we're going back to thinking that all means all true. Because of this one false, that means that the entire, all of A is false. Any of these could be true, but because it's not true, it has to be false as well. So C is 1, 2, 3. C is going to be all false. So D is going to be equal to an empty bracket, which will also give you an error on MATLAB.